Okay.
Okay, great. So, so I guess what we'll talk about today, I'm going to assume that most, if not everyone here, is relatively new to data science, or at least they're sort of somewhat dabbled in it, but aren't unsure of what it entirely is. So, for that purpose, I've sort of framed this workshop as in terms of a question format. So, we're starting off with what exactly is data science. So, we'll talk about some definitions. Because there's a lot of them. We'll talk about some related academic fields. So I assume you all are students, and I'll talk a little bit about my own journey to data science in college. Next, we'll talk about what you can actually do with data science. So we'll talk about 3 avenues that you can sort of apply data science in, particularly industry, research, and social good. Next, we'll talk about is data science actually for you? You know, would you be interested in it? Would it be a good career path for you? So we'll talk about some of the skills that you'll learn, some of the industries in terms of career that are hiring data scientists, and who you might be, in terms of a person, some of your traits. And then we'll talk about how you can actually do data science. So things like what classes you can take, what online resources that you can access for free, of course. And then also, how you can build your resume in case you're really interested in entering the field. And then finally, I have a short workshop where I'll showcase Jupyter Notebooks, which is an extremely common tool used for data science in today's world. And we'll do some sentiment analysis on some tweets, which will be pretty cool. Cool. So I guess starting off with what exactly is data science, it's a pretty new field. There's a lot of definitions. So here's a couple definitions. Here's one from Wikipedia that says an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data, and applied knowledge and actionable insights from data across a broad range of application domains. So that's quite a mouthful, and it tries to encompass a lot. And there's things like algorithms, scientific methods, systems that sort of pop out at you, structured, unstructured data. But it's still sort of a mouthful and doesn't really help, in my opinion, in terms of debunking what this field is. Here's another definition that I find a lot more useful. So data science is the practice of using data to try and to understand and solve real world problems. And this is from a book called How to Build a Career in Data Science, which you can find for free online. And I like the definition a lot more, and I would totally agree with what that is. So a lot of the fields that we'll talk about in data science are some fields that you might have heard of before, like computer science or math. But at the end of the day, what makes it different from those fields is the fact that you're using data. And today, in today's world, we have a lot of data, almost too much data. We have way too much data, and we don't know what to do with it. But we know that perhaps we can get some useful information from it for a large number of purposes, some of which we'll talk about today. But I think that's probably the most simple and most useful definition that we can sort of focus on. So if you want to explain it to your grandma, or if you need to use it at a dinner party, that's probably a definition that I would rely on. So some more things to sort of debunk what data science is, right? We can look at job titles. So there's the traditional data scientists, but there's also data engineer, there's data analysts, there's research scientists, there's machine learning engineer, there's BI engineer, which is business intelligence engineer. And there's a lot more job titles that are common today. And that's because of 2 reasons. One, it's a very new field. So people are calling it all sorts of things. Not everyone is super sure what it's about, but they know it's pretty useful, and they know it's highly in demand. So that's the first reason why there's so many job titles. And the second is that there's, data science encompasses a lot. Just because you're a data scientist doesn't mean you won't be programming, or you'll be doing math. Sometimes you might only do programming, sometimes you might only do math. So there's a lot of different definitions out there. And more proof of that is looking at the related academic fields. So we start off with computer science, which I mentioned before. Programming is pretty key in data science. There's statistics, which is also very huge in data science. But there's also math, there's operations research or industrial engineering. There's business, there's econometrics. So data science as a field encompasses a lot, which is good and bad. It's good because if you study any of these fields or anything related to these fields, then chances are you're already doing some kind of data science, or at least you're really prepared for a career in data science. And it's bad because it can sort of not help a lot with thinking about what data science specifically is. It's not specifically like computer science where you might say, oh, okay, I'm studying computer science, so I might want to be a software engineer. But if you see the data science, there's a lot more things that you can do. But at the end of the day, what's common between all job titles, all academic fields, is that you're using data. So something that might help is also talking about my journey to data science. So to clarify, I just graduated from UC Berkeley with majors in data science and economics, and I'll be going to Georgia Tech in the fall to pursue my master's in analytics, which is also sort of a subfield in data science. So I've been around data science for around a little over 2 years. So since my sophomore year. And the first my interaction with data science was my first data science class, which is called Data 8, Foundations of Data Science at UC Berkeley. Huge course, very popular course, one of the first data science courses that actually sort of came about in the US in general, in any sort of college. And you can actually, the best part about it is that you can access it free. So if you look at data8.org, you'll see all the different iterations of the course online, fully for free. And we'll talk about it a little bit later. But this was my third semester in college, so my sophomore year. Until then, I came in as applied math major. I thought about economics. I thought about operations research as majors, and I wasn't really sure. I knew I didn't really like math too much, although I liked it a little bit. So I was sort of dabbled in a lot of different things, and then I came upon data science, and I really enjoyed that course. So that takes us to the next semester, where I actually joined my first data science club. And this isn't to say you have to join a club of any kind, but I just sort of, I think it's good to sort of immerse yourself in some kind of data science community. And Data Science Society at Berkeley was sort of my first data science community and my first interaction with data science in general. And in this particular semester, I actually hosted data science workshops, kind of like this one, except a little more of a technical capacity. So I taught basic Python and Excel to other Berkeley students, and also mentored some students while they were working on their own projects. So this was actually sort of my first interaction with data science. And then that summer, I had my first data science internship at Endorsify, which is a marketing startup. So I was a data science intern and I did some machine learning work. And machine learning might be something that you're familiar with. It's a very popular field of computer science, very popular subfield in data science as well. So I did some machine learning work for them, which mostly focused on improving some existing algorithms in the company's product. The next semester, I did something sort of similar, where I worked as a data science consultant. So remember what I said about job titles? I wouldn't really pay too much attention to them, but I think it's also good to show that there's a lot of different job titles there. But I did this time I didn't really do machine learning. I did backend software development. And cloud architecture, which is basically I made a chatbot and I put it on the cloud. And again, this was for a startup, and this was sort of me delving a little deeper into data science. And then the next semester, spring 2020, which is when the COVID pandemic started, I actually led a data science team for PayPal. And I actually, one thing to note is that for Oust Labs and PayPal, I actually got these opportunities through my data science club. So the power of community is certainly shown there. But yeah, I led a team of 6 Berkeley students to perform, and this time it was business intelligence and natural language processing work, which are also sort of big subfields in data science. So already you're seeing, like a pretty large variety of types of work being done, job titles, companies. We started off with some startups with Endorsify and Oust Labs, and then we have PayPal, which is a pretty large fintech company. And I also did some research at Berkeley. So I was an RA for 2 PhD students at the Haas School of Business, which is a business school at Berkeley. I did some econometrics research, which, again, is a subfield of data science, not entirely, doesn't fully define data science, but it's part of it. And that summer, again, I was a data science intern for a startup where I did machine learning and optimization work. And then for my senior year, I did some more research at Berkeley where I did again, NLP work or natural language processing work, but this time on a sociology project. So I think two big takeaways. One, there isn't really a straight path to data science. I started off with a class, and then I went to a workshop, and then I started doing different kinds of work, starting with machine learning to software development to optimization. But this by no means is not a template for data scientists or I would say this is actually fairly rare. And I would say no two data scientists often have the same path in terms of becoming, or getting into data science in general. But also, so yeah, in general, biggest takeaway is, diversity in the types of work that you'll be doing, the people that you might be working for, the context that you might be working in. So it could be marketing, it could be supply chain, it could be sociology. Really, there's a lot to be done, and there's a lot that you can do. So what can you actually do with data science? I sort of touched on this a little bit, but let's talk about what might be sort of pertinent to you guys. So the short answer is anything. And I like to sort of divide it up into three like sort of sectors. So industry, research, and social good. So starting with industry, you can deliver business insights using analytics if you choose to work for certain companies. You can create predictive models using machine learning, which is huge today. You can forecast trends in the stock market, which is also huge. Finance is a big industry, and time series analysis, which is a subfield of data science, would allow you to do that. And you can also develop apps and dashboards with real-time analytics, which can be pretty informative for a lot of companies. If you aren't really compelled by industry, you might consider research, in which case you could work on cutting edge machine learning research, for example, such as deep learning or NLP. A lot of these buzzwords you might have heard of, and they're actually very new. There's a lot of research going on there. So if you're interested in research, that might be an amazing sort of pathway for you. You might develop predictive models that help identify and predict disease risk in hospital patients. Data science has a huge sort of footprint in healthcare, and obviously identifying, and a lot of the work revolves around identifying disease risk in patients. So if you're interested in that, huge sector, and of course it can be really fulfilling as a data scientist as well. And then finally, study how to use data science securely, responsibly, and ethically. Like I said before, there's a lot of data in the world. A lot of you are probably on social media, and a lot of those companies have access to your data, right? So how do you think about using them ethically, and make sure they're not using, you're not using personal data for your own benefit? So ethical data science is also a huge field in research today. And then finally, there's social good. So data science can be used for a lot of good. You can use statistical tests to check for voter fraud in elections. So as many of you might be aware, there were presidential elections last year, and a lot of people actually claimed fraud. And then some data scientists came up and said, hey, we've done the statistics on this. This isn't fraud. And we can say that for, with a very high probability. You can develop interactive data visualizations. So if you've ever gone to the New York Times, maybe to check for COVID cases or anything really, chances are you've seen a data visualization, and those visualizations are done by data scientists. So a lot of these newspaper websites have a team of data scientists working on really great data visualizations. And then finally, something a little more relevant today: create dashboards to display the latest COVID trends in an area. So that's definitely something that you've all interacted with. Whether it was just looking up cases in your area through Google, or another website like the New York Times or whatever else. Really, contributing to that is extremely amazing, because you're making information accessible to millions of people about a really important piece of news and information. So there's really a lot you can do with data science. There's a place for everybody, in my opinion. So if any of these pique your interest, or all these pique your interest, I would definitely encourage you to sort of consider data science as a field at some point. So how do you actually do data science? We've talked about a lot of different academic fields. We've talked about a lot of different industries. We've talked about research. So how do you actually get started? So one great way to do that is classes. So a lot of these might not be accessible to, maybe middle school or high school, but certainly accessible in college. So I would start with computer science, particularly programming. Programming tends to be a very big part of a data scientist's job today. So, and you don't have to be an expert programmer, but knowing particularly Python is an extremely useful skill. And the great news is, you've probably interacted with Python at some point. Python is one of the premier choices for an intro to programming course. So even if you haven't taken it, I really wouldn't fret. There's people that take learn Python after college. So, as old as I am or even older, and then become data scientists. But programming is definitely an important sort of skill to have. And I put some of the languages there that are most commonly used, but really, just knowing one of them like Python or R should do just fine. So math tends to be pretty big as well. So calculus and linear algebra, again, a lot of people take them in college. It's totally fine. If you can take them in high school, even better. But really, there's no rush really. But having that mathematical background is extremely useful in a lot of data science work. And the same goes for statistics, which is actually an even bigger part of data science. And the only real difference between statistics and data science, in my opinion, is that data science is enabled by programming. So a lot of statistics, requires a lot of computational power. And until about maybe the last 10 to 20 years or so, people were pretty much unable to perform those statistics, to perform, what we call today data science, because of computational limitations. But over the last decade, we've been able to achieve that. And that's sort of, what has expanded data science as a whole. So having some statistics background, particularly a subfield like probability, is extremely useful. So classes are a great way to sort of dabble in data science. Another great way to interact with data science is online resources. So there's, data science being a new field, there's a ton of free online resources that you can access. I really like Medium blogs. I use them a lot when I was starting out. One that I would recommend is called Towards Data Science. So I think you might just have to go to towardsdatascience.com, or if that doesn't work, just look up Medium Towards Data Science, and then you'll have all sorts of topics for all sorts of skill levels. So whether you're just starting out and trying to learn about what data science is, or if you're more advanced and trying to learn about a specific topic like machine learning, chances are that information will be there for you for free. There's also blogs, so by other data scientists in industry that are really illuminating, so you get to hear from not just students like me, but also actual data scientists in the field. So I put two people there who I personally follow, so Susan Shu and Eric Weber. Really great sources of information. And then finally, I mentioned this before, but Data 8, Foundations of Data Science, is the first data science course I took. And it's the first sort of intro to data science course at UC Berkeley. And at data8.org, you can find all their resources and for the class for every semester that has been active for free. And there's even a textbook that's meant for people who have had practically no experience programming or doing statistics. So if that sounds like something you'd be interested in, definitely check that out. And those are just some of the online resources. If you look for one, you'll find probably 10 others on your way. So yeah, definitely take advantage of those. And then finally, I'll talk a little bit about how you might want to build your resume. So if you've taken some classes, if you've read about data science online, and you're thinking about, hey, how do I get into this field? How do I market myself, or how do I get more experience? So I mentioned coursework. Coursework is a great way to get more experience and knowledge. Personal project is one of the biggest things. So doing any kind of personal project, whether you want to make an app on your own or a dashboard, and it doesn't necessarily have to be directly related to data science. It can be a project that showcases your expertise in a particular subfield. So let's say you made a website for your own for your own writing, or you made a dashboard with some sports analytics, or whatever you want really. It doesn't have to do, every project doesn't have to have, it doesn't have to be that, you have to use computer science, math, and statistics in every project. You just use one thing, a subfield of one thing, just having sort of showing the initiative to sort of try working out data science kinks and like sort of things like that on your own shows a lot of initiative, and it also is really helpful for yourself developing your data science experience. And a side note to this is making a GitHub is extremely useful, because you can actually showcase your personal projects on the GitHub. You don't have to have your own website. I personally don't have a website, and I just put all my projects in GitHub. And that way, if you're applying for internships or applying for jobs, or you just want to sort of have a free storage solution for your personal projects, GitHub is a fantastic way to showcase that. Next, I would also suggest Kaggle. So Kaggle is sort of like LeetCode, if you've sort of interacted with that, except for data science instead of software engineering. So Kaggle allows you to basically do data science in a simplified manner. So it gives you data and it says, here's what you need to do, and here's how to do it. And it gives you, Jupyter notebooks to sort of do the data science on. And there's a lot of people on there. I've personally done several Kaggle projects when I was first starting out with data science, and I thought that was, an amazing way outside of my classes to get more experience doing data science work. So again, another free resource. Definitely encourage checking that out. There's also competitions where you can compete with people globally. There's companies hosting competitions and datathons and hackathons like that. And speaking of, the last thing I would say is hackathons and datathons. So, if you're doing the hackathon here at Mission Inspired, that's great. You have something to add to your resume. You're getting experience. And again, it doesn't necessarily have to be data science work. If you're just programming and trying to build your programming skills, that's absolutely fine. If anything, programming is like a lot of the work behind data science. So, doing, attending events like these and doing datathons, which are hackathons, but more sort of focused towards data science, can be a really great way to not only build up experience, but also market yourself through your resume. Cool. So finally, I'll talk about, we've heard about what data science is, we've heard about what it entails. Is it actually for you? Would you be interested? So I guess that one thing we can talk about is the skills that you might learn. So a lot of these I've touched on before, but it's a very quantitative field. You'll learn a lot of programming. You'll become an adept statistician. So you'll, do you learn about subfields like probability, hypothesis testing, time series, which are sort of niche and, again, not really at the high school level, more at the collegiate level, but certainly extremely useful. I personally think they're great life skills in general. Definitely if you're someone who's quantitatively oriented, data science might be a great fit for you. So programming, statistics, and mathematics, definitely, expect to become proficient at those. Next, so, if we want to think about all the different, people hiring data scientists, right? You have technology. So you have your social media, you give your big tech companies, Silicon Valley, you name them. But then you have consulting, you have finance, you have academia, if you're interested in research, you have real estate, media, government, healthcare, really, any industry that you can possibly think of is probably looking for a ton of data scientists. So if you have an interest in any of these fields, independent of, whether you, like, let's say you got into the media industry and then you hadn't really considered data science as a subfield, but then now you're immediately thinking about data science. So you have two interests that sort of go hand in hand. You have media and data science, and so naturally, there's a lot you can do with that. So really, any industry that you might be particularly interested in, there's data scientists being hired. So I wouldn't, worry about, oh, if I'm a data scientist, would this industry not really be interested in me? So that's one thing. And then finally, who you might be as a person. So you like working with data, and data comes with in a lot of different forms. It comes with numbers, it comes with text. If you worked with an Excel file before, you've worked with data. If you worked with tables before, you work with data. And if you sort of like taking a lot of information and sort of making sense out of it, or summarizing it, or doing anything that's useful with it, data science is probably a great fit for you. You enjoy working on open-ended, tough problems quantitatively. So I mentioned before, there's a lot of data today in the world, and a lot of people are struggling to sort of think about how do we make sense of this? How do we make sure that we can actually use this in the right way? So they'll say, for example, if you're working in technology, if you're working at a social media company, let's say you're working on Instagram, and then your manager comes up to you and says, hey, we just noticed our people are 30% less people are using the Instagram stories feature. What's going on? And there's so much that could be going on, right? But having access to Instagram's database, they would expect a data scientist like you to sort of make sense out of all that noise, and then come up with something really focused and clean to help them improve their business. You want to specialize in multiple academic fields, not just one. So if you're anything like me, having come into college, thinking about applied mathematics, and then doing economics, and then I even thought about computer science, and I thought about statistics, and then finally ended up majoring in economics and data science. So if you feel like you're all over the place, if you feel like you would like a lot of different things, data science might be the place for you, considering how interdisciplinary it actually is. So if you can't really decide, and I personally, still haven't decided. So if you want sort of a place to sort of funnel that in, data science is great for you. And then finally, you love working with people. One of the best parts about data science is that there's a fantastic community. It's a very new field. People are learning all the time. People are sharing resources, and a lot of them are free too. So there's a big community. And oftentimes, even as a data scientist in industry, your research, your social good, whatever you're doing, you're very likely working with other people, either face to face or in our case across the world. And I personally think that's an extremely satisfying part of the job. So working on these tough problems and these open-ended problems for whatever reason with other people is certainly extremely satisfying. Great. So I guess I'll get into the workshop now. And let's see, hopefully I can switch to my Jupyter notebook. So I guess before I switch, Jupyter notebooks, as I mentioned before, are a really common data science tool. And then sentiment analysis is a particular subfield of data science that is really popular. It has to do with text data. And you're basically using computational methods to look at whether this text data is portraying positive or negative sentiments. So if you had a piece of data that said, I'm so happy today, that's, that computational method would tell you that that piece of text, I'm so happy today, has a lot of positive sentiment. You can actually put a number on it too. You can say it's, 3, or we'll see that happening. And then, if I say, today wasn't a great day, and that piece of text, today wasn't a great day, that would be labeled as having negative sentiment. So we'll actually be applying sort of that methodology to a whole bunch of tweets. And hopefully I can give you sort of a demonstration of data science at work. I guess before I move on, are there any questions at all that people have? Again, feel free to stop me at any time. Especially with this demonstration, if there's something that's not showing or anything like that, feel free to stop me at any time. So this is a Jupyter notebook. You can tell by the Jupyter sign over here. Fun fact, Jupyter notebooks actually started at UC Berkeley. So I was very lucky to sort of be around this technology as it was up and coming during my own undergraduate career. And Jupyter notebooks are essentially meant to be very interactive applications. So first, you can see there's a lot going on here. So what's going on? So first we have text here that, if I click on it, I can edit it if I want. So I can say, I can add some text here and it instantly saves it that way. But then there's also code. So this is Python, and everything that we'll be doing today in Python will be in Python. And another disclaimer, you don't worry about understanding all the code. If you can, great. Otherwise, I'll walk you through all of it. And you definitely don't need to understand the code to get something out of this workshop. So there's code as well. And a Jupyter notebook is organized by cells. So this is the first cell in the entire notebook. And we wanted this text to be, this cell to be text because I wanted a title for this notebook. And then the next cell is also text. And it says importing packages. So before you start any sort of work in programming, you usually want to import a package. And then the very next cell is actually full of code. So one of the biggest advantages of Jupyter notebooks is that you can sort of intermingle text and code on the same notebook. And if you compare that to Microsoft Word, where you can only type, but you can't really put code, you wouldn't want to code Microsoft Word. And then if you also talk about a text editor, like maybe Visual Studio Code or Sublime Text or Atom, you can code, but you can't really put text in there. So Jupyter notebooks is a great way. And data science tends to be very interdisciplinary. You want to sort of communicate a lot of thoughts usually in Jupyter notebooks. So that's sort of why Jupyter notebooks were created, to enable data science. And we'll actually see that we can actually create graphs and such in the same notebook along with text and code very soon. So the first thing that we'll do is we'll want to import these packages, and there's several packages here, and each of them allows us to do different things. So for example, the pandas is an extremely popular data manipulation library in data science. And of course, you'd want data manipulation if you're working with data. Matplotlib is an extremely popular data visualization library. So we're basically importing all these packages so that we can use them in the future. So I'm gonna select the cell and then I'm gonna click run. And then you can see that that asterisk sign turned into a 1. That's just telling me that it's the first cell that was run in this notebook. And then the asterisk sign was sort of the progress indicator for that cell. And you'll see that throughout this notebook as well. So we just imported all our packages, and now we're ready to sort of start working with data. So let's load in the data, and these 2 cells will help us do that. So I'm gonna run that, and then I'm gonna run this cell, which will display the data that we have right now. So you can see there's a lot going on here, but the main thing to look at is this part right here, which is one particular tweet. And these tweets are actually from Donald Trump, and they were happening around, I think, 2016. Actually 2018. We can verify that by looking at here. So this particular tweet happened in October 16, 2018, and this was the tweet that Donald Trump posted. So there's a lot of data here, and a lot of it is pretty there's a lot going on, and so our job is now to sort of make some sense of it. And then our ultimate goal is going to be assigning, each of these tweets some sort of sentiment. So, by the end, we'll know whether this particular tweet was a relatively positive tweet, or was it a sort of a more negative sentiment tweet. Great. So the first thing we want to do is we want to organize all this data. And then to do that, we're going to create a data frame. A data frame is just a table. It's just called a data frame because of the pandas library, but I would just think of it as a table. So we're making a data frame called Trump. And so once we do that, this is sort of what our data frame looks like. So, like I said before, it's just a table. You have an index, so you have some sort of tweet ID. You have the time that it was posted, and then you have sort of this weird URL hyperlink type of data called source. You have some text, so there's some tweets, some text here, there's some links here, and then you have the retweet count, so the number of times that it was retweeted from the time of its posting. So a lot of data here, and we can actually even look at how many tweets we actually have, and we actually have 10,000 tweets. And one thing to note is that we're loading 10,000 tweets. We just did that in maybe a minute or 2 minutes, and that was mostly just me talking. So again, data science is constantly enabled by computational power, and I'm just doing this on my laptop. I just have a regular MacBook, and I'm able to do this on my own pretty instantaneously, which is awesome. So now that we have this data, let's analyze it. So let's start with this weird source field, right? Like, what's going on here? We have some Twitter links. We have Twitter for iPhone. We have Twitter for Android. So maybe it's organized by tweets that were made from an iPhone or from an Android phone, right? So let's investigate that a little more. So let's look at some of the values that are particularly unique values in our field. And that doesn't really help too much. There's, we can see there's only 8 or 10 different kinds of sources in our data set, but still that's not super helpful. So let's clean that up a little bit. So here I'm performing some string manipulation. And again, you don't have to understand any of this code. I'll be telling you what it's doing. But once we replace that, let's look at what the source looks like, right? So from this, we've now gone down to this, right? And we've sort of cleaned up, we've basically extracted this part of each source. So we can see that it's somewhat cleaner, it's somewhat, more informational. And then once we clean that, we see that every source is basically one of these things. So either you're posting a tweet from your iPhone or your Android, which we always suspected, but there's also a Twitter web client. There's a media studio, there's Twitter for iPad, there's Instagram, there's Twitter ads. So there's really, a lot of different sources here, which is pretty useful. And right now what we're just doing is we're cleaning up the data, we're getting a feel for it, we're exploring it and seeing what it looks like. So there's a lot of different devices here, right? So one thing that would be useful is looking at what are most commonly used. And we're actually going to make a visualization here. So this code basically will make a bar plot, and it'll show us the number of tweets by source. And I'm going to click run again, and voila. So one thing to note again is that you're seeing a data visualization in between code and text. So Jupyter notebooks are really useful for that. So here on the x-axis, we can, if you sort of tilt your head a little bit, we can see all the different devices from which tweets are posted. And you can see clearly that we have a number of tweets on the y-axis, and the two most common tweets are from iPhones and Androids, which is actually pretty useful, right? So we don't really have to worry about all these different other sources. So the rest of our analysis will focus on iPhones and Androids. And this is why it's really important to sort of clean your data and then sort of explore it a little bit, because then you can get insights like these. Next, we'll look at the distribution of tweet sources. So again, I'll run some code that'll end up in a visualization. And then here we have a little more complex graph, but so we have iPhones in blue, and then we have Androids in orange. And then we can see like how many more, so we can sort of see like, let's say 2016, for example, we can see that Androids had, there were a lot more tweets from Android phones in 2016 than iPhones. But then over 2018, 2019, we can see that there were almost no Android tweets. Most tweets were actually from iPhones. So, if you were sort of thinking about, if you're analyzing tweets, tweet sources, particularly, the difference between people posting, or actually particularly in this case, Donald Trump posting, between Androids and iPhones, then, you can clearly see that after around mid 2018, he pretty much stopped using an Android and just using an iPhone, which is, it's not particularly useful information at this point, but it's certainly something that interesting to think about. And the main point is, you can create data visualizations like these to do any kind of analysis. Next, we'll do some more analysis. We'll analyze the difference in tweet times across devices. So first thing we'll do is we'll add an extra column. We'll add, just some dates, and we'll convert it to the right time zone just for some data cleaning purposes. And then first thing we'll do is we'll graph the distribution of tweet hours for different tweet sources. So this is by hour by day. And you can see that, so when, Donald Trump uses an Android phone, he most often uses it in the morning, whereas for the iPhone, he used it a little more in the afternoon and the night. And the nighttime is actually fairly similar. And then next we'll look at the same thing, except for before 2017, because we saw here earlier that 2017 was around when he switched from an iPhone to, or an Android to an iPhone. So if we sort of look at only the data before 2017, we see that, we can see a slightly different behavior if you compare the top two graphs together. So again, something interesting to look at. So now that we've sort of explored our data set a little bit and come up with some visualizations, we'll finally do some sentiment analysis. And what we'll do is we'll import something called a Veda lexicon. So the Veda lexicon basically gives you a polarity, something called polarity. So polarity is I mentioned before that, by the end of this, we'll be able to say whether a tweet was positive or negative, and then we'll be able to put a number on it. So that's what our polarity is. It's basically telling us how positive or how negative a certain character is. So you can see here that there's a dollar sign and a colon has negative 1.5 polarity, which doesn't make a lot of sense. So if you look at some other words, so for example, ache has a negative polarity because when you're aching, you're probably hurting and you're not feeling great. Whereas something like achievable is a little more positive, right? It's a little more hopeful, it's a little more inspiring. So it has a positive polarity. But again, aching has a negative 2.2. So this lexicon has a lot of different polarities. In fact, let's see how many tokens it actually has polarities for. And there's 7,500 different words or characters that it has. And so you can think of it as a dictionary, except each word is defined by a polarity. It's defined by a number that tells you how positive or negative it is. And basically, what we're going to do is we're going to map that to every tweet that we have. And then we'll be able to tell, so for example, if you had a simple tweet that says, I'm sad, you might have a polarity of 0 for I'm, because the I'm isn't really positive or negative, it's just describing me. then sad might have a polarity of -3. So then your overall polarity would be -3. And then that way you could tell that, you know, the I'm sad tweet is pretty negative. So hopefully that makes some sense. So again, some more code to calculate overall sentiments. This particular cell has a lot of code in it, so it's going to take like 30 seconds. But yeah, in the meantime, if there's any questions, feel free to ask me. But so far, what we've done is basically clean some data. We've made some visualizations to sort of explore some data. And then now what we're trying to do is for every Trump tweet that we have, we're going to calculate whether each of his tweets were more positive or more negative. And then we'll actually come up with some pretty interesting visualizations after that. I guess while it's still loading, oh, actually, it just loaded up. So that's great. And then so a sneak peek of what sort of, so all of this is basically just data cleaning, it's data transformation. And again, I'm not assuming any programming knowledge here, so you don't have to understand any of this. But now we'll finally get to sort of assigning the polarities to every tweet. And then what we end up with is this is the same data set that we had initially, but we're actually merging it with something that we created. And then now we actually have, so first what we've done is we've taken every text and we've actually removed all the punctuation from it, because the punctuation doesn't really tell you whether something's positive or negative. So we've removed most of the punctuation there. And then finally, we actually have polarities that are aggregated for every tweet. So you can see this is a relatively positive tweet. This is a very negative tweet, actually. A little more positive, a little less positive. And we have that for all of our 10,000 something tweets, which is awesome. And we've basically been able to do this. You know, if I ran it straight through, it would probably take us a minute. So that's pretty great. So I mentioned that we might do some pretty interesting visualizations. So let's first look at this, like some of the most polarized tweets. So the most negative tweets basically sorted by this number here. So just looking at all the negative tweets. So a lot of bad things going on, violent killings, poisonous, illegal activity. You know, it's not hard to see that these are very negative tweets. And more positive tweets, you know, congratulations, a truly great football team, the supporters are the strongest, smartest, most hardworking. So, you know, for every tweet, we can see that we have polarity assigned. And then finally, we can do something that where we look at the distribution of tweet sentiments containing keywords. So if you follow the news, you'll know that New York Times is a little more liberal and more Democrat aligned versus Fox News. This is a lot more Republican and conservative. And Donald Trump himself is a conservative. So we might expect, you know, some of his tweets that include Fox News to be a little more positive, whereas some of his tweets that include New York Times might be a little more negative. And let's see if that's true. So run this cell. And so we have zero polarity here, with this side being positive and this side being negative. And then as we hypothesize, a lot of the tweets that include Fox News are actually, you know, a little more positive than the New York Times tweets, which is actually kind of funny to watch, right? And then finally, we'll also do the same thing, except we'll use the keywords Democrat and Republican. And again, we'd expect something similar to this, where we have Republicans a little more on the positive side, and then Democrats a little more on the negative side. And so we'll run code. And again, we can see that Republicans are slightly more positive, although a little less so than compared to New York Times versus Fox News. But you can see that Republican tweets are a little more positive usually, and then Democrat tweets are a little more negative. So if you didn't really know who Donald Trump was before, you certainly know sort of what his political ideologies are. So this is basically, you know, a really great example of sentiment analysis, which is just one subfield of data science. And this whole time we've sort of mixed code with data visualizations. I would ignore all of this. It's just a warning. It's just Jupyter notebooks being a little annoying. And then, you know, some text as well that we can include. So then, you know, let's say you were sort of presenting this to someone, you could, you know, let's say you wanted this cell, by default, it's just code, but if you wanted to write some text in it, you could go to Markdown, and then you could say, we now know that Donald Trump is a Republican. and then you save that, and then that's your conclusion. And of course, you'd want something to be a little more formal, but for the purposes of this workshop, I'll keep it a little simple. Cool. That's practically the end of my workshop. I'll stop sharing my screen for now, but if you guys have any questions about my presentation or my workshop, I'm happy to share it again, or I'm happy to answer questions in general as well. But yeah, thanks for listening.
Awesome presentation. Honestly, I felt like I learned a lot, even though, I mean, I'm not one of the hackathon participants.
Great, yeah.
Hi, I have a quick question.
Yeah, totally.
So how exactly does machine learning fit into data science? Is it part of data science or is it a separate field?
Yeah, great question. So so it's sort of, if you sort of imagine a Venn diagram, right? Where you have computer science in one big circle, and then you have one data science in one big circle, you'd see machine learning sort of in the middle of that. And what I would mean by that is machine learning is something that originated from computer science, but is used a lot in data science, right? And in fact, machine learning is actually, machine learning not just uses computer science, it uses a lot of math, it uses a lot of statistics particularly. So it uses a lot of things. But particularly for data science, one big use case of data science is that let's say, something that wouldn't really work, but if you wanted to try to do is, let's say you have some COVID cases for 2 months. So if you take yourself back to last summer, you had, data on March through May, and then you wanted to see, you wanted to forecast what COVID cases might look like in the future. So what you would actually use in that case is some type of machine learning. So machine learning is one of the biggest use cases that it has is predictive power. If you're able to pull off a good machine learning model, there's some models that get up to 95+% accuracy. So you're basically having a really high accuracy of sort of predicting the future, right? And of course, that comes with its intricacies, and it's a very popular field in general. And I guess to answer your question, it's a part of data science, and it's used a lot in data science as well. So I would just think of it as like a subfield in data science, but also in computer science. So it's a field that uses a lot of different fields, but it's certainly a very big part of data science. Good question.
Thank you.
Yeah.
Do you have any last minute questions? Okay, then I guess we can end here. Good job. Thank you for speaking for us today.
Absolutely, yeah. If you guys are participating in the hackathon, good luck. Yeah, hopefully you guys will consider data science. So yeah, have a good day, guys. Thanks.